Hi everyone, I'm Jenny Stewart. Thanks so much for joining me today. Today we're going to talk about finding the greatest common factor in polynomials. And given the mini lecture that I'm going to do right now, combined with the example that I have worked out step by step on finding the greatest common factor in polynomials, you should be able to do the prime factorization of the coefficients of the polynomials, to find the variables of the lowest degrees in each of the terms of the polynomial, and find the greatest common factor of the polynomial with 75% accuracy. Okay, so let's get started. First of all, let's refresh for a second about what a polynomial is. Polynomial, poly is many, nomial means many. So it's an expression of many terms. Two or more terms, okay? And a monomial is one term. And these polynomial terms can consist of coefficients, which are the numbers in front of the variables, variables in themselves, and exponents to the positive degree, okay? Now, why in the world would you want to learn about greatest common factors? Well, greatest common factor is one of the first steps in several solutions to some major problems in math. For instance, factorization, when we're going to factor trinomials or factor binomials, you need to know how to find the greatest common factor. Simplifying radicals, simplifying rational expressions, you need to find it. And also, when you get into intermediate algebra and college algebra, you can solve quadratic equations by factoring polynomials, again using the greatest common factor, setting that equal to 0, and solving for that. Okay, so it really is a very powerful skill to have in your mathematical tool. All right, so let's get started. What is the greatest common factor of a polynomial? The greatest common factor of a polynomial is a monomial, a one term, the largest one term that divides evenly into every term in the polynomial. So I have this example up on the board. 30x squared y squared z squared plus 50x to the 5th y to the 3rd plus 60x squared y to the 5th z. So 3 terms in my polynomial. We're going to break it down into 2 steps. First, we're going to work with the coefficients of each of these terms. So I'm going to write them up here. I've got a 30, a 50, and a 60. And we're going to find the prime factorization of each of those coefficients. So 30. Common method of finding prime factorization is using the prime factorization tree. So what do we can see right away that this is divisible by? 10. So that's 10 times 3. 3 is prime, so we're going to circle it. And 10 is 2 times 5. So the prime factorization of 30 is 2 times 3 times 5. Now 50, again, 10. 10 and 5. 10 is 2 times 5. So 50 is 2 times 5 times 5. And then 60, again we see that 10 as a factor, times 6. 10 we've already seen is 2 times 5. What about 6? 2 times 3. Okay. So 60 is 2 times 2 times 3 times 5. Put it into order. Now, the greatest common factor of this prime factorization, we just see what's in common. All of these have a 2 in common, don't they? Mm-hmm. So we're going to bring that 2 down. Do they have any other factors in common? They have a 5 in common. So I'm going to bring that 5 down and I'm just going to multiply it. Okay? Any other factors in common? No. So that's 10. So the greatest common factor of the coefficients, that part is 10. Now let's look at the variables. We could do exactly the same process on the variables, and we could do that because we have little exponents here. But what if we had huge exponents? What if we had y to the 32nd? We don't be wanting to write y to the 32nd out, right? Much easier way, an alternate way to do it is you just take, first you see what variable is in common in all 3 of the terms, and then you take that variable to the smallest power, okay? So x is in all 3 of the terms, yes? So we're going to put our x here. And what's x to the lowest power? x squared, because that's x to the 5th and that's also x squared. What about y? Do we have y in all of them?
Yes.
Yep, y. And y to the lowest exponent is?
Y squared.
Y squared. And what about z?
Only 2 terms.
Only 2 terms have the z. The middle term doesn't have it, so z is not part of that greatest common factor. So our greatest common factor is 10x squared y squared. Okay? Any questions on that? All right, so like I said, I have the handout that has the step-by-step solution. I have 5 questions I'd like you to look at, and you find the greatest common factor on your own. And then I'd like you to switch papers and just check the work of each other. Not to worry, it's not graded. It's just to give you some hand-on experience about working these, okay? Let's take about 20 minutes to do that, and then we'll check our progress and see how much we've learned today, okay? Okay, so thank you so much for being here. I really do appreciate it, and I hope we've all learned how to find the greatest common factor, which is the smallest term that goes evenly into all terms of the polynomial. All right, thank you.